In this lesson, we're going to do a quick review of motion in 2 dimensions. That's going to be projectile motion. So we'll use the equations of motion to help us solve some practice problems. So first things first, what is projectile motion? Basically, a projectile is anything that is thrown. It could be a ball, a stick, a stone, an iPad. It could be anything that is thrown. It is projectiled into the air. Okay? It will move up and down, it can move horizontally, it can move in both the horizontal and the vertical directions. These two are actually independent of each other, okay? So you will have to separate the two speeds. So this special case, again, projectile motion. Just a quick thing to note, if there is no air resistance, you will see a little curve, a little arc shape. We call this shape a parabola. That's the name of the path that it follows, like a little mini semicircle. If we had air resistance, of course, it will be smaller. The air is going to slow it down. It's going to be passing through the air, so the air resistance, it will be a little bit slower. So it's a quick side point for you there. So here is an example of a projectile motion. You will launch a projectile, maybe at an angle. You will have a horizontal component and a vertical component. So that's when you'll use the h cos theta and the h sine theta and break them up into two. An important thing to note is that when this ball is thrown, you will have a starting speed, but when it reaches the top, over here, the vertical speed will be 0. Because if you remember, if you just take something and you just throw it up, it will get slower, 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 stop, and then it will come back down, getting faster, faster, and faster. Fun fact, if I had a speed of 20 going up, the final speed will be minus 20. I guess if I was halfway up here, if this was 10, this will be minus 10 meters per second. And of course the top would be 0. So that's a little breakdown on the vertical thing. So Vy would always be 0 in this case. This is the maximum height. And then it's going to come back down, and it's going to get faster and land back into the ground again. All the way through, we have a vertical acceleration. Gravity is pulling this down. Gravity, which is minus 9.8. This is where the minus is really important now, because if you're moving up or down, we have two different directions. So gravity is downwards. Down is usually negative, so negative 9.8. Horizontally, to the right, there is no acceleration. Horizontally, it will be a constant speed. So here's a little recap of that. Sometimes you know that the vertical speed, if let's say something is being dropped down, you can say that the speed at the very top of the motion will be 0. So that's what this one means here. The starting speed in this case would be 0. If I threw it up, doesn't matter. Again, it will reach a certain height and it will come back down, like I mentioned earlier. Every single time, the speed at the top is always 0. Horizontal speed is constant. The starting and the final, doesn't matter. It is a constant speed. The acceleration horizontally, remember x is horizontal, is 0. There is no horizontal acceleration. There is a vertical acceleration in the y-axis, minus 9.8. So these are some important points that will help you solve problems. So there are four main equations of motion. This one you can actually get away with not doing. You can solve one of these and then solve another and you'll get the same thing. But these four are the equations of motion that we can use to solve anything for the vertical component. If you have any acceleration, we will use these equations of motion, okay? I'm going to focus on the first three, to be honest. Horizontally, of course, it will just be distance equals speed times time. There is no acceleration. That will be a simple formula, okay? So these are some of the meanings of this. Displacement, starting velocity, final velocity, acceleration, the time. It's a little toolbox that we would use to solve. So I've got the little equations over here. These are for the vertical. This is for the horizontal. So I'll split it up. Vertical and horizontal. You fill in all the numbers that you are given in the question. In fact, sometimes you will not be given a question. If it says a ball is thrown into the air, automatically you're expected to know that this is minus 9.8. This is minus 9.8. So there you go. That's a 9, by the way. And then you will say, what is the speed at the maximum height? Well, straight away, you know that the speed of the maximum height will be 0. Stuff like that. So you'll start filling in some numbers, whatever is given to you. Remember, you need 3 pieces of information. Maybe the time was 5 seconds. You need 3 pieces of information to solve for anything at all. If I have 3 pieces, I can use any of these formulas to find out what I need. For the horizontal, I will need 2 pieces of information to find out what I need. I need 2 for the horizontal. Maybe if I calculate the time here, I can use the same time for the horizontal. That will help me. And then I can figure out the speed. So there are many, many different types of questions you can get, and I will not be able to cover them all. So I will just do a few examples in this video. So this is a little toolbox. Write down the symbols that you'll need. Fill it in. 3 pieces for vertical and only need 2 for the horizontal. Choose an equation and then you can figure out your answer. Okay, here's a quick question. A ball is thrown vertically into the air with an initial velocity of 20 meters per second. What will the velocity be after 3 seconds? Okay, so what is it asking me? So, I'll write it out separately, I don't want the whole thing. So let's say x equals vi equals vf equals a equals and t equals. Let's keep this information here. I have the time, that's 3. That's 1 piece of information. I have initial velocity, that's vi initial, that's 20. That's 2 pieces, I need 1 more. I only have 2 numbers. Aha, wait, it is thrown in the air. Minus 9.8. 1, 2, 3. What am I asking for? What will the velocity be after 3 seconds? So I'm asking for a final velocity at some point in time. Vf, Vi, A, and T. Which equation should I use? Vf, Vi, A, and T. So there's my Vf, there's my Vi, there's my A, there's my T. I can use the first formula. So I just checked, put the numbering inside. What we'll do is Vi plus AT, that's 9.8 multiplied by the time, which is 3. Of course, because it's minus 9.8, it will become minus 29.4. Your final answer will be negative 9.4. So the ball will be on its way down. If it's going up, the speed will be positive. If it's coming down, the speed will, of course, be negative. Nicely done. All right, so if I was to take a ball and drop it, and at the same time throw a ball horizontally, you will find that actually both balls will land at the ground at the same time. No matter what my horizontal velocity is, it does not make a difference because it's gravity that's pulling it down. Gravity will bring them both down at the same rate, minus 9.8. Of course, if I've thrown it with a larger horizontal velocity, it might go further, So you can find the horizontal distance traveled by using distance is speed multiplied by time. The horizontal speed multiplied by time. So we're talking about the initial velocity. Don't forget, it can be broken up into horizontal and vertical components. So if I give you an initial velocity of 50 meters per second, and I said to you the angle was 45 degrees, if you wanted to find the horizontal component, just like we did in the previous lesson, we will do the hypotenuse, cos theta. So I will do 50 cos 45, and I'll get my number. If I had my vertical, I will do sine 45. And in this case, it's the same because 45 degrees is exactly halfway between the vertical and the horizontal. So that number is okay for, in this case, to be the same. So here's a different sample question. Cannonball is fired from the ground at an angle of 60 with the speed of 72. What are the 2 components? Like we said, horizontally is always going to be cos. Vertically is always going to be sine. So I could do 72 cos 60. In this case, I'll get 36. And the vertical will be sine 72. Sine 60, that'll be 62.35. Here's an exam style question. 3 parts to it. A student stands at the edge of a cliff and throws a stone horizontally over the edge with the speed of 18, only horizontal, and the cliff is 50 meters above a flat horizontal beach as shown in this diagram. So this is 50 meters of the height, the y-axis. What are the components of the initial velocity? How long after being released does it strike the beach? The time, basically. What is the final vertical speed just before hitting the ground? What would the vertical speed be? So, first question, the components of the initial velocity. I know it's thrown horizontally, so the x component will be 18, and actually the y component will end up being 0 for this one. So that's actually a good, easy start. The vertical being 0, the horizontal being 18. For part B, it's asked for the time. I know that it fell to the ground below, which is minus 50 meters. I know the starting speed was 0, we just mentioned it. I don't know VF, I don't know time, but I do know acceleration, minus 9.8. That's always minus 9.8. Horizontally, I only really have the V, so there's not really much I can do with that right now. So if I want to find the time, I need 3 pieces of information. 1, 2, 3. This is perfect. I can find the time. Now I need to figure out which of the formulas that I need to use. If I want to go back and check which formulas I have, we will have the formula sheet. Let's have a quick look at the formulas that we will need. We need to find time. So unfortunately, we cannot use that one because we don't have the VF. This one looks good. I cannot use this one either because that also has a VF. This also has a VF, not good. Which means the best is this one here. I can use this formula to help me find the time. Don't be scared if there are 2 T's here. I know the VI is 0, so this will all just become 0 anyway in my question. So that's not going to be a problem for us here. So let's see if we can figure this out. We're going to take this rule to solve for time. You can use Shift Calc, or you can rearrange to get T. So if I was to put Shift Calc in, I will write minus 50, then I'll press alpha equals, and then I will get my VI times T. Well, I don't know T, but I know VI is 0. Anything multiplied by 0 will be 0 plus, I don't even need to write it, a half A, which is negative 9.8, so I could have just put a minus there if I wanted to, doesn't matter. Minus 9.8 multiplied by T squared. You will do alpha X, or alpha any of the letters that you have, and then you will square it. You press Shift Calc 0 equals, and then you will get your answer. I'm going to make a little video on that as well to show you how to do that. Otherwise, you can rearrange to get the T square root of 2x over A. I've shown you how to rearrange the formulas. If you really want me to show you again, fine, I'll quickly show you. VIT plus a half AT squared. That becomes 0, I already know that, so X equals a half AT squared, very nice. I'm going to take the half to the side, opposite of a half, and multiply by 2, so I'll get 2x equals AT squared, very nice. I want to remove the A, so this is now going to have to divide both sides by A. That way that will cancel my A's. So now we have 2x equals just T squared. I don't want the squared, I will do this. Square root, to remove the squared, to cancel it, I will do this. So this is what I've just written over here. Very good. Put in the numbers in, and you will get this number, 3.19. I now know my time. Perfect. And of course, if that's my vertical time, the horizontal time will be the same. So now I know the time horizontally. For this side, I need 2 pieces of information to find a third. If I asked you to find this distance, you can easily just multiply this. D is V multiplied by T. So that's great. The question did ask for the final speed as it reaches the ground. I know that I'm looking for VF. This is what I need. I have all of this information. I can use any of the formulas I like because I have everything except what I need. The easiest formula is just simply VF equals VI plus AT. 0 plus negative 9.8 times by the time which I just found, 3.19, and I will have my vertical speed over here. A little extension, if I asked you for the overall speed, the total speed, the resultant speed, you'd have your horizontal of 18, and I'd have my vertical of minus 31.3. How would I find this, the resultant speed? What would I do here? Maybe an angle. But what would I do here? I would use Pythagoras. C squared equals A squared plus B squared. If I wanted to torture you and ask you a question like that, I can easily do that, and now you know how to solve it. You'll, of course, take the square root at the end as well, and we did this in a previous video as well. Thank you.